right. Thanks for coming in. I'm Marc Gratacos. I'm the managing partner of a company called TradeHeader. We are a consulting company focused on data standards such as CDM. We are a CDM contributor, and I'm going to present today's session on initial margin reporting using CDM. Okay, so what we have been doing recently, and yeah, I'd like to share that with you. The presentation has four main blocks. I'm going to just provide some background and set the scene for the topic. And we'll discuss two main methods for calculation of initial margin, the standardized schedule, and then is the SIMM. I will see a couple of demos on the implementation of those methods using the CDM. And I'll talk a bit about the challenges and next steps around this project. This is an internal project that we are doing at TradeHeader, but if anyone wants to be involved, that will be great. And see next steps in terms of the project development. Right. So let me just provide like a video that I was testing just a minute ago, just to set up the background on what we are discussing. I know Amy, Vernon, and Tom discuss collateral management, but just to set the scene around initial margin, let me just play this video. It's 1 minute. So sorry about this.
What is collateral in the derivatives market, and how can it make the economy safer? Think about how a secured loan works. A person takes out a loan to buy a new car and puts up the car as collateral. If she can't repay the loan, then the lender uses the car to offset its loss. Collateral in the derivatives market works in a similar way. Assets are put up to protect each counterparty from loss. In derivatives, however, the market value of the trade can vary from day to day. That's where variation margin comes in. Say two parties enter into a 10-year interest rate swap. If the market value of a trade changes by $1 on any given day, then $1 in collateral is delivered. That way, a firm would be paid what it is owed, even if the trade is terminated that day. New regulations require most firms to post variation margin on their derivatives trades. In addition, many firms, including financial institutions, are also required to post a pot of collateral before they trade with each other. This is called initial margin, and it's a kind of buffer that insulates the surviving party against further losses following a default. These are important changes. Collateral is a backstop that protects market participants and the economy as a whole. The collateral requirement is just one of the 5 key reforms we have seen in the derivatives market that make it more transparent, resilient, and safe.
All right, cool. So we all know now what's initial margin. So we have set up the scene. Sorry for this. For the discussion. Let me just close this one. Right. So what I'm going to discuss is we have the scene. We're going to focus in this session around initial margin. How do we calculate initial margin, and how can we standardize the calculation of initial margin? What we have in terms of the environment is we have a regulatory pressure, right? So since the crisis, the Lehman crisis, we have had a series of increased reporting pressure, not only for transaction reporting, but also for collateral. And initial margin is not a difference on that. We have seen regulatory bodies asking for the methods that you're using for initial margin. And depending on the thresholds that you have, that financial institutions have in terms of volumes, they are required to report the methods that they are using for calculation of initial margin. And in some cases, they are required to use a special set of calculation methods for that. Okay, so we have this environment of increased regulatory pressure. If we look at in terms of what we have, is that firms, financial institutions in the past, internalized these methods. They weren't public. Each firm were developing their own models for calculation of initial margin, and it was kind of almost like a black box. So one of the key principles that we are seeing from the regulators is there is this list of 8. but I would like to focus in number 3, which is consistent methodologies for calculating initial and variation margin. And this is specifically the discussion that we are having today. Okay, there are other key topics around the applicability of margin practices across the OTC derivatives industry, whether firms need to report for both sides on one side of the transactions. So there are a set of requirements here that are defined by regulators. I'm going to focus around the methodologies for the calculation of margining. So what we have in the industry nowadays is there are 2 main families of initial margin calculations. And we're going to see is the implementation of those in CDM. The first one, which is the simplest one, is what we call a standardized schedule. And the second one is a family of methodologies, what we call quantitative portfolio models, in which probably the most famous one in the derivatives world is the SIMM. Okay? So the whole point about this is I don't think firms are gaining any competitive advantage of creating these models, implementing these models in-house. Why don't we standardize this and just bring it as part of the CDM in an open source way? Okay, that's the whole objective. So first, let's start with a simple one, which is the standardized schedule. What we have, there are 2 points in the standardized margin schedule approach. One is the simpler approach in terms of developing a quantitative model for initial margin. And it's very conservative, right? So it has a higher cost for financial institutions in terms of the amount of collateral they need to post. Another point I would like to make is that it's a simple model, and in a sense, the simplicity relies that there is a sort of a multiplier that gets assigned depending on the type of asset class that we are including as part of the portfolio of your trades, and the duration of that transaction. So you can see there is a multiplier here that is part of the formula to calculate the standardized schedule. And this factor changes depending on the asset class and the duration of your contract, right? So for example, like the interest rates 0 to year duration only has a 1 factor against, for example, equity or commodities, which have a value of 15. This is oversimplified, as you probably are guessing now, because first of all, because these are just numbers in terms of there is some sort of calculation around this, but at the end of the day, we are fixing a factor here. The other, as you can imagine, is that in a single transaction, you can have multiple risks associated to that transaction. And this methodology only allows one asset class to be picked, what we call the main one, but not multiple of them, right? So the method is a bit oversimplified. There is a standard formula that is being used in the industry to calculate this, and it's what most of the firms are actually using in the market nowadays. Okay, why? It's because it's quite simple, as you can imagine. So this is the actual formula, and these are some of the net standardized IM that needs to be calculated is depending on the net current replacement costs and then the gross initial margin. That these are the functions that we have implemented using the CDM. Okay, right. So how do we implement this in CDM? What we do is take advantage of the CDM structures that we already have. As Tom was saying in the previous presentation, CDM is not a data model. Well, it provides a data model, but it's much more than that. It provides a set of functions that you can develop and you can use on top of the data model. And one of the most important set of functions, from my perspective, is the set of qualifying functions. So CDM provides a set of functions that allow you to classify products, right, in different layers, like at the asset class level, but also at the product level. And what we did is, in order to implement this methodology, we used these qualifying functions to be able to define in which asset class the transaction can be classified. And we can do that just directly using these functions that we have available in the CDM. Once we have that, we can create the functions that we need to make the calculation that we need for the standardized schedule. So the contribution that we will prepare for CDM will include these functions, but the calculation functions rely on the qualification functions that we already have in the CDM to be able to classify the product and assign the actual risk factor that is defined within the table. Okay, so we can assign the asset class by reusing the existing CDM components that we already have available right now in the CDM distribution. Okay, so let me just show you a demo of the implementation of these functions. We used the Rosetta tool to develop this, but you can use Legend or whatever. In this case, yeah. So it's just a video showing the use of Rosetta and implementing these functions. And then, yeah, so what we have is we have defined a function called getStandardizedSchedule, which implements the function that I just described. And we don't go into all the detail, but it reuses the qualifying functions to get the input values that we need for this type. That includes the asset class, product class inputs. So what we are going to get is we're going to get a trade. And for that trade, what we can use is we can get the actual gross initial margin. So first of all, we are going to just use an interest rate fixed float swap in CDM. So this is a transaction. And that transaction that gets qualified gets assigned the specific asset class, the specific product class, and then based on the notional amount, and gets all the information that is needed to be able to generate the standardized schedule. Okay, and then one of the things that we have as a next step on this would be to run this through a portfolio of transactions. So for this demo, I'm just showing you just like as a single trade, but the idea would be to run this in a portfolio to be able to have the whole portfolio get calculated and have the net amount. Okay. So what we have is, yeah, we have all the parameters that we have in the initial function. We pass that, and we will get the gross initial margin as the output. We'll get the IM requirement that we need as the output. Yeah. Okay. So we can test the function of the calculation of the, once we have the schedule, we can test the calculation of getting the initial margin, the gross initial margin, by just getting the outputs that we have generated from the schedule and get the actual amount. Okay. And that's it. Yeah. In this case, this is the gross amount that we need to post in USD. Okay. So these are the functions have been developed. With that, we are able to generate the standardized schedule method. Okay. Okay. So we have seen that this is a bit simplified in a sense that we are not getting all the risks that we may have in our portfolio of transactions. So the second methodology that we implemented is the SIMM. SIMM stands for Standard Initial Margin Model. It's developed by the firms that are members of ISDA, and it provides a common methodology to be able to calculate, again, initial margin, but basically like taking into account all the risks associated to a particular transaction. The SIMM expects an input to perform the calculation, and there is a complex formula that calculates the actual amount of initial margin, but it expects an input that it's called CRIF. That's what it's called the Common Risk Interchange Format. It's like a big table, a big spreadsheet, with all the different inputs that are required to be able to calculate SIMM. What we have done in the CDM is create a set of functions to be able to generate the CRIF file. So CRIF expects these columns to be populated for each one of the transactions that you are including for your initial margin calculation. You can have, we will see that for a single transaction, we can have multiple risks. So we can have multiple rows for a specific transaction. So that means that we are not simplifying and just picking one of the risks, but we're actually taking all of them into account for a particular transaction. If going into more detail on this, what we have is, depending on the risk type, CRIF is asking us to fill out a set of parameters that need to be included to be able to calculate SIMM. So, for example, for the risk IR curve, we need to complete all the different columns, specifically, like, for example, the tenor of the contract. For inflation, not so many are required. We only require the actual code for the index, but not the buckets and the labels. So it kind of is a kind of a matrix in which, depending on the risk, you are required to fill out all the columns. In some other cases, you are not required to do so. So you can see that it's quite complex in terms of the amount of data it requires to be able to fill out the whole matrix. So why do we need to like implement this when we can have that in an open source library? So that's what we're trying to do in this implementation. What we did is, first of all, again, we are using these qualifying functions to be able to extract, to be able to classify the product, right? So we classify the product. We know exactly in which risk type and qualifier, which risk type are applicable to the particular transaction. It could be more than one, as I said, using the qualification functions. And once we know that, we extract the information for the particular product that is required to fill out the matrix, the CRIF file. And then we implement the functions to be able to create that, right? So to be able to output the expected output that we need in CRIF to be able to calculate SIMM. And finally, we calculate the SIMM amounts based on the CRIF file. So what we have completed in the project, and it's not everything, but almost, is, and I will discuss that, some of the roadblocks that we have, but we are able to complete all the columns except the amount and the amount USD, and I'll discuss that in a second. But the idea is that once, for a particular interest, for example, for an interest rate swap, once we have the qualification function and we classify that, we extract all the information that we need based on the paths that we have in the CDM object, right? So we are able to extract all the information. In this case, for interest rates, we apply that to all the asset classes. And this will be, for example, a case of an interest rate. What we have is, we have defined two main functions. One is what we call the get risk. And we generate for a particular product, we generate all the information that we need as inputs for the CRIF table. And then we have a CRIF set of functions that are in charge of extracting all the information that we need for each one of the cells. Okay, so we have developed all the logic to be able to complete the CRIF generation. Okay. Yeah, so this is again. I'll show you a demo again, and then this is implemented in the CDM as well. Sorry about this. Oops, sorry. Right, so using, again, Rosetta, we have implemented the functions to be able to implement CRIF. We have the get risk function that for each one of the takes an input as a transaction and then generates all the risks for a particular transaction, depending on the classification that we have using the CDM. Some of the challenges that we found is in terms of the qualifying functions, is in terms of the composability of those functions. The functions are being developed with the idea of initially to be able to report like what we call the ISDA taxonomy. Those have been remodeled recently, and they are much more composable now. And we think that for some of the asset classes, they work perfectly now, but we still need to do some additional work for things like equities and commodities. Sorry, I think I stopped this. Oops, sorry about this. No, sorry about this. It wasn't showing the demo. Okay. Oh, God. Sorry, I think I had a problem with the video. Apologies on this. Oh, gosh. And, well, anyway, what I wanted to show you is the use of the functions that we have implemented for the CRIF. I think there was a problem with the video, but it's the same idea that I show you with the standardized schedule. So the idea to show you the functions and then getting the outputs on CRIF and SIMM based on those functions. Sorry about this. Okay. Okay. So some of the challenges I was mentioning before, the use of the qualification functions. We have been doing a lot of work on the CDM for this. We still need some additional work, mostly on credit and commodities. We'll be able to show you the full report in Rosetta, I think, in the future. Right now, what we are doing is developing the whole set of functions, but the idea would be to use like a set of blotter at the end that we can show you everything. And finally, we depend on access to external sources of reference data. We would like to define some of the API calls that we need for things such as a risk engine and the things like FX conversions for the amount in USD. Okay. Right. So one of the things that I didn't discuss before is the limitation on these two parts and the amount. The actual amount that we need to generate in the CRIF generation file is depending on sensitivities. And to get the sensitivities for the different products, we need a risk engine that provides that. So we explore two possibilities. One is the use of the open source risk engine that is available. It's now supported by Acadia, but other firms are contributing to that. The problem there is the sensitivities that we're getting from the open risk engine are not exactly the same sensitivities that SIMM expects. So there are some differences there. The other approach that we considered was to use QuantLib because the open risk engine is based on QuantLib. And we wanted to use QuantLib for, we wanted to see whether we could use directly QuantLib, but that's quite complex because it's almost like developing your own risk engine from scratch. So the next steps on these are probably like partnering with an implementer that has already a risk engine and being able to have the full implementation from the qualification to the amounts using a risk engine. Yeah, so I'm not going to go into a lot of the detail in terms of the differences in sensitivities, but there are some differences that don't allow us to use directly the use of the Open Risk Engine directly for SIMM. Yeah, sorry, question.
I wanted to mention one thing because I come from Acadia. So the ORE is actually the backbone of Acadia's SIMM.
Okay.
So I'm not entirely sure what you mean by the sensitivities. I don't know the sensitivities because, like I said, we are using ORE to calculate SIMM for our clients.
Yeah, great. So then let me follow up then, and maybe it's our misunderstanding of the outputs that we are getting from ORE. That could be the difference that we are getting there. And then finally, and the other point I wanted to make is next steps. So we want to complete the CRIF implementation. We'll use the risk engine, probably ORE, to complete the full end-to-end process. We need to get FX conversion with some external reference data to be able to get the amounts in USD for the trades that are not USD based. With that, we'll be able to complete the amount and the amount USD functions, and we'll be able to generate the full CRIF. And then with that, we'll be able to just get the output on SIMM with the formula that we have implemented already in the CDM. And finally, we'll contribute all the CDM work to Finos to be able to use standardized schedule and SIMM directly in CDM. Any questions? Thank you very much then. I'll be around in the CDM booth as well. If you have any questions, happy to follow up with you. And if you want to participate in the project, this is an internal project we are developing. But yeah, like happy to collaborate to further expand the CDM work for initial margin calculations. Thank you.